One, students. In the first part of the lecture, we have discussed conversion of degree measure to radian measure, and the formula to convert was radian measure is equal to pi by 180 into degree measure. Then 1 radian is approximately 57 degree 16 minutes, and 1 degree is approximately 0.01746 radians. Then this also we know 1 degree is 60 minutes and 1 minute is equal to 60 seconds. This was what, students, we have already revised in the part 1 of the lecture 2. Today means now we are going to study conversion of radian measure to degree measure, and the formula is make degree measure in this formula as subject. So degree measure dm is equal to 180 by pi into radian measure. Chronology will be radian to degree, degree to minutes, minutes to second. Reverse chronology. The chronology what we had in the previous conversion was second to minute, minute to degree, degree to radian. Here the reverse one. Radian to degree, degree to minute, minute to second. Now students, here 3.1 we are doing main question 2. Exercise 3.1, answer to part 1. Theta is equal to 11 by 16 radian. Okay, so students, pay attention here. We use the formula degree measure dm is equal to 180 by pi into rn, means radian measure. Pi is 22 by 7, so 1 upon pi will be 7 by 22 into 11 by 16. This many degrees. 11 1s are 11, 2s are 2 1s are 2, 90s are. Then students, we can still divide by 2. So this will be 45 and this will be 8. So we have 45 into 7 by 8 degrees. Now students, 45 into 7, 7 5s are 35, 28 into 31. So this is 315 upon 8 degrees. The next 3 steps, students, the next 3 steps I want all of you to concentrate maximum. Now go for simple division. I am writing here. Go for simple division. 8 divides 315. 8 is a 24. So 11 minus 4, 7 and 5. 8 9 is 72. Remainder is 3. This is remainder. This is quotient, and this is D. We have to write in the form Q R by D. Writing a fraction, students, in the form of mixed fraction, which we have studied in standard 5. So our quotient 39 integer 3 by 8. Now separate out the integer part and fractional part and convert it into minutes by multiplying by 60. So the reverse process, while converting radian measure to degree measure, we have to multiply by 60, and while converting degree measure to radian measure, we are dividing by 60. 4 2s are and 4 15s are. So this is 39 degree. 15 by 2 is 7 integer divided directly. Right? Again separate out the integer part and fractional part and convert it into seconds. So our final answer will be 39 degrees, 7 minutes and 30 seconds. So fractional part we have to separate out and first convert it into minute, and then students minute to what? Seconds. This is what we have to do. That's all students. Now second sum students. -4 radian. Question 2 part 2, theta is equal to -4 radian. Students, minus convention shows rotation of initial ray in which direction? Clockwise, and positive convention shows rotation of initial ray in anti-clockwise direction. That's all. So keeping minus sign outside, 180 by pi, this will be always common, into 4, this many degrees. 2 90s are and 2 11s are. So finally we have 90 into 28 divided by 11. So let us multiply 28 into 9. 9 8s are 72, 2 9s are 18, 18 plus 7, 25. So this is 2520 upon 11 degrees. This much is very simple. I go by simple division. 2520, 11 2s are 22, 32. Again 11 2s are 22, 100, 11 9s are 99. Remainder is 1. This is remainder, this is quotient, this is D. We have to write in the form Q R by D. So this is converted to 229 integer 1 by 11 degrees. Separate out integer part and convert fractional part into minutes. So 11 divides 60. 11 5s are 55. So remainder is 5. Again write this as Q R by D. Then this is written as 229 degree plus 5 minutes plus 5 by 11 into 60 seconds. So 311 divides 300. 11 2s are 22, 80, 11 7s are 77, 3, and I write it approximately. This is 229 degree, 5 minutes and 27 seconds. This is your answer. And negative sign I am carrying forward outside the bracket. Intentionally I have not written just to avoid confusion initially, because minus sign is just carry forwarded. For the answer here also we write students the negative sign afterwards, right? So just the negative sign shows the convention, student. As such it has no rule. It is simply a convention. And negative sign indicates clockwise direction. That's all students. Very simple. Okay. Now we are going for the third sum. So this, students, we have to very perfectly understand. Theta is 5 pi by 3 radians. Okay. Answer 2 part theta is equal to 5 pi by 3 radian. So degree measure is equal to 180 by pi into radian measure this many degrees. So 180 by pi into 5 pi by 3 this many degrees. Directly pi cancel out. 360s are 65s are 30. 65s are 300 or 6 5s are 30. This is 300 degrees. No need of any other discussion here. Theta force 7 pi by 6 radians. So students, this is written as dm is equal to 180 by pi into rn, and so this is 180 by pi into 7 pi by 6. Pi and pi cancel. 6 1s are 6, 30s are 37s are 210 degrees. That's all. Very simple, students. Very simple. Okay, students. Now we are doing question 3. Now, students, we are doing question 3. A wheel performs 360 rotations in 1 minute. Then, what is the radian measure of angle in 1 second? A wheel, students, performs 360 rotations in 1 minute. Then, what is the angle in radian measure traveled in 1 second, or you can say angle rotation in 1 second. Okay, now students, all of you concentrate. A wheel performs 360 revolutions in 1 minute. In 1 minute, sorry. How many revolutions? 360 revolutions. Now, students, 1 minute is nothing but 60 seconds. So, in 60 seconds, 360 revolutions. So, students, in 1 second, how many revolutions? So, number of revolutions in 1 second is equal to 1 into 360 divided by 60, and that is 6 revolutions. Understood, students? What is the main part of question here, students? In 1 minute, a wheel performs 360 revolutions. So, in 1 minute, in 60 seconds, number of revolutions are 360. So, students, in 1 second, how many revolutions are there? Answer is 6. Now, 1 rotation or revolution means 2 pi radian. In radian measure, I told you, if you remember, in angular degree measure, 1 rotation is 360, and in radian measure, 1 complete rotation is 2 pi radian. So 6 complete rotation will be 12 pi radians. So angle in radian in 1 second will be 6 revolutions multiplied by 2 pi, and that is 12 pi radians. That's all. Because in 1 revolution or rotation, the angle is 2 pi. So in 6 revolutions, the total angle will be 12 pi radians. Students, one of the most interesting concept. I hope all of you have understood carefully. In 1 minute, number of revolutions, students, are 360. It means 60 seconds. Number of revolutions are 360. In 1 second, how many? 6. Now all of you know that in radian measure, 1 complete revolution is circumference of unit circle, and that is 2 pi, because r is 1. So in 6 revolutions, the radian measure of wrinkle is 6 into 2 pi, that is 12 pi radians. This is what, students, we have to understand. Now let us do example 2, where it is 6 radian. To convert it into degree measure. Students, let us do now example 2. Converting into degree measure. Example 2. Our theta is 6 radian. Okay, students, we use the formula dm degree measure is equal to 180 by pi into radian measure. So this is 180 by pi, means 180 into 7 by 22 into 6. So 2 11s are and 2 90s are. So this is 90 into 42 divided by 11. This many degrees. Now, students, if I multiply first 42 into 9, 2 9s are 18, 9 4s are 36, and 37. So this is 3780 upon 11 degrees. Execute formal division and write a fraction in the form of mixed fraction. 11 3s are 23, 4 8, 11 4s are 44, 4 0, 11 3s are 33. So remainder is 7. Write it in the form of QR by D. So this changes to our quotient is 343 integer 7 upon 11 degrees. Separate out the integer part and fractional part and multiply by 60 to convert it into minutes. So divide 420 by 11. 11 3s are 43, 90, 11 8s are 88. There is 2. Write it in the form of Q R by D. 38 integer 2 by 11 minutes. So 334 degree plus 38 minutes plus 2 by 11 into 60 seconds. 120 divided by 11, which is approximately 10.9, and that is 11 seconds. So 343 degree, 38 minutes, 11 seconds is our answer. Positive convention shows that rotation of initial ray is in anti-clockwise direction. That's so now I am under the impression that all of you have understood this very perfectly, and I don't think you should have any problem. Still, if you have any problem, you are free to discuss. This is useful in physics, chemistry also, more in physics. So you should keep my credit when Ankit sir teaches you conversion of degree to radian and radian to degree. So this is the conclusion of part 2 of lecture 2. Remaining sums of the exercise will complete in the next lecture. Thank you.